Good morning or good afternoon, depending on your time zone. I'd like to welcome everyone to the Fibre Channel Industry Association's Making of Fibre Channel Standards webcast. My name is Joe Kimpler, and I'll be your moderator today. The first thing that I'd like to do is send out the FCIA's best wishes to everyone in this unprecedented situation. So please wash your hands, keep your distance, and we will all make it through this crisis. As a quick reminder, the FCIA is over 25 years old and has been providing remote education for long before it's mandated. And we provide monthly education webinars covering a wide variety of topics, everything from this webinar of making fiber channel standards to solutions, implementations. If you would like to download this, you can go to the fibrechannel.org/webcast. You can also download it from the screen. Lastly, a PDF of the slides will be posted to the FCIA fibrechannel.org/webcast for reference material later. The presenters today, our presenter from Hewlett-Packard Enterprise will be Barry Maskas. Barry is a storage networks technical consultant for HPE with over 40 years of product design and development experience. Again, my name is Joe Kimpler. I'm an independent storage networking consultant with over 35 years of sales, business development, and engineering experience. As a moderator, I'll be taking questions during the presentation, and I'll be interjecting them at the end of each section. We will also have some polling questions for the audience. There'll be 2 of them, so please do your answers to answer them as quickly as possible. This helps us to make our webcast better. Lastly, if you don't have a chance to ask a question during the presentation, we'll have time for a Q&A session at the end. Allow me a brief commercial about the FCIA. It's a mutual benefit, nonprofit, international organization of manufacturers, system integrators, developers, vendors, and industry professionals. It promotes the advancements of fiber channel technology and conforms to the existence and emerging T11 standards. We work on multi-vendor interoperability for hardware interconnect and protocol solutions. Provide promotional and marketing for fiber channel solutions, educational awareness campaigns, hosting public interoperability demonstrations, foster technology and standards conformance. And we provide a market direction for the T11 task group, and this presentation is sponsored in cooperation with the FCIA's Education Committee. On this webcast, we're going to pull back a curtain on FC standards process, and what we'll discuss is what makes a standard, the difference between a standard and a spec, the benefits of standards when architecting solutions, who's the T11, the standards process, the actual fiber channel standards, how to decode acronyms, and then current fiber channel standards that are under development. This is important for FCN VME2, and then some Q&A. Just to push out a polling question, I'm going to go ahead and push that out now. So if you would start voting, you should see a polling question that says, how important is compliance to the fiber channel standard in your company's purchasing decision? If it's critical and you don't use any proprietary features, if it's very important, let us know. If it's a nice to have item, let us know. And if it's none of the above, that you just pick the technology that seems to fit your application, that would be great. So go ahead and start voting now if possible. Excellent. Thank you very much. We have about 50% said critical and about 50% said very important. So if we look at the agenda, Our first section will discuss what makes a fiber channel standard and the difference between a standard and a spec. With that, I'd like to turn it over to Barry.
Hello, everyone. Thanks for joining. I really appreciate your taking the time to give us your feedback on standards. You know, in the U.S., there's a unique standards model, unlike any other place in the world, and it's comprised of independent organizations, and the U.S. government actually promotes this idea of getting together as an industry or to make an industry and to kind of level the playing field across the world for technologies, especially in this sector which we are in, called the information technology sector. One very important aspect of standards is that it actually enables companies to compete worldwide. It acts as a leveling process so that anybody, you know, with a material interest can join in, can participate in the market, and benefit from the, you know, acceptance and wide interoperability of the products that are produced. One of the things that we don't want is, you know, a lot of disparate organizations espousing their own plan, you know, and I just kind of jokingly have Bernie over there and Al Gore. I mean, I think of Bernie as sort of espousing, you know, to change the world, and Al Gore being more, you know, systematic and focused and, you know, let's get organized. So we want to have standards. We want to have a large organization behind the standards, and we want that standard to be a national standard and, in fact, an international standard. And so, you know, we get to the idea, you know, anybody can write a specification, and you'll probably see specifications for so many different things. But that doesn't mean that anybody could make that thing or anybody could interoperate with that thing. And then you may see a few companies get together and say, well, let's promote this spec, right? But they're not going to promote it in the way that it becomes a national standard, right? It may be acceptable for 1 or 2 use cases. It may live for 3 or 4 years and then fade away because, you know, it's not adopted, it's not accepted. I remember years ago working on something called the future bus. It was going to be this standard that was going to take over the world. You know, had a lot of participation, but it died in 2 years, right? Nobody went forward with it. Things like that happen all the time in this information technology sector. Compare that to fiber channel, 25 years, still going strong, still has a lot of investment and is forward-thinking and forward-looking. And this is the idea that the standard is based on global expert opinion. You know, we have a team of experts who are constantly working to develop the standard and to further the standard and to enhance the technology to take advantage of new opportunities and do that in a way that it's available to anybody with a material interest. And participation, as you'll see soon, is wide across this standards body, specifically the T11 standards body. You know, and this is a consensus process. It's not one company off in a corner, you know, cranking it out and everybody's just, you know, giving it a head nod. I mean, there's really a broad participation. There's a vote. And that vote can stop things, or that vote can promote things. You know, so every company has a voice. Everyone who chooses to participate has a voice and has a vote. So, as I was saying, there's an international organization, ANSI, and the underneath ANSI, we have structure. These organizations provide formalism in the language that can be written to describe a standard. They provide publication services. They provide maintenance services. So one thing that makes a standard different than a spec is that this idea of a life cycle. You know, we in the under the ANSI INCITS umbrella of governance, you know, we have the SCSI standard, right? The T10 organization. We have the Fibre Channel T11 organization. We have the ATA organization, right? So these are national standards organizations that fall under governance of an organization called INCITS. And we have very strict procedures. And unlike other organizations, you know, as I mentioned, T11 for Fibre Channel, T10 for SCSI, IEEE for Firewire, the IETF, you know, for Internet, and iSCSI, InfiniBand Trade Association for InfiniBand, you know, USB Implementers Forum, NVM Express. Again, we're seeing this idea of consortium bodies or work groups. The PCI SIG is a community. FCIA is a nonprofit organization, right, with a mission to promote technologies. And recently they've taken over the small form factor standards, SFF, which we all, you know, that use transceivers in this industry appreciate that organization standardizing the form factor and the content of the EEPROM, right? So we have all these organizations. Not all of them are producing national standards. A lot of them are work groups, they're task groups, they're consortiums, right? They're paid-to-play organizations, and they change, and there's dynamics, right? So the thing about standards is that, you know, there's accountability, and that accountability is not short-term, right? It's a long-term investment as a national standard and maintaining it. But we don't work in a vacuum, right? So T11 and T10, you know, and T13 don't work in a vacuum. We are cross-organizational. We work with all these different nonprofit consortiums or you know, industry associations or whatever kind of another form. And, you know, a few examples here, you know, we just recently worked with the T10 team to update the SCSI protocol over Fibre Channel, right? Because that standard is jointly managed and maintained, right? We worked with the NVM Express organization in order to craft the FC NVMe and FC NVMe2 standards based on the NVMe OF spec. And, you know, we work with FCIA. And, you know, these are not just casual relationships. We have formal liaisons. We report every 2 months what that organization is doing. We report to them what we're doing, and we work together to make standards current and maintainable. So as I mentioned, the whole idea of the standards is that it's a living document. It's a life cycle, right? And you know, we can kick a project off. You know, we've had you know, ghost presenters. People just show up and throw an idea into a committee forum, and that idea may take hold. I remember that's kind of how NVMe got the committee's interest. Some folks showed up, said, you guys really should be looking at this. And, you know, and it became, after, you know, quite a bit of work and years of meetings, a standard, right? And then it became a second edition standard, right? Fundamental to standards process are face-to-face meetings, right? This isn't done by webinar. It isn't done by, you know, writing up a, you know, an RFC and sending it around for comments. You know, it is done through face-to-face meetings with a very structured group, very formal documentation that's archived, that's iterated, that's voted on to be incorporated into standards. The writing, the actual wording of the standard is reviewed word by word by the committee before that technical committee will promote it for further review, public review. One important aspect of this life cycle is public review, right? The standard will not get approved until it has been through a public review. And so anyone who has a material interest can comment, and every comment has to be addressed and resolved and documented, right, in terms of what was done to address it. And then we have this idea of a balloting process, right? So every voting member of the organization can cast a ballot, you know, and in so doing, that ballot can contain comments. And again, those comments have to be addressed before a proposed standard can be promoted forward. And to gain final approval, right, so then we have a board. There's an idea of an executive board, which are industry professionals. And that board then has a vote on whether or not this can be promoted, you know, up to ANSI for national standard. And then it becomes in a maintenance mode. And if there is errata, if there are additions or modifications that need to be made, there's a very formal process for that standard to be updated and maintained over its life cycle. And then some standards, you know, that have sort of reached the end of their life, they'll go into what's called a national maintenance mode, no further work on them, but they're still available. Just as a sort of an aside here, just to kind of reinforce the idea of how standards work for you. I don't know if any of you have heard of T12, right? We often get the question, wait, we've got T10, we've got T11, we got T13 under INCITS. What the heck happened to T12? Well, one perspective is that, you know, 45 years ago, the light bulb industry, fluorescent light bulb industry, decided to model the naming of their standard around the diameter of the tube. And that's where the 12 came from. And there's actually a T5, and, you know, there's different format. There are two that are popular, T5 and T12. But that became standard. It became government promoted it. It became pervasive in all government buildings, right? It became a national standard and then became an international standard. And you know, believe it or not, it's still being updated. You know, today you can get lead-based fluorescent tubes, you know, energy efficient. They can use the same fixturing, or you can upgrade the fixturing, right, compatibly. But it has a long-term advantage. And it's open, right? Anybody can participate in this industry and benefit from it. So just kind of that idea of having a material investment, right? We all benefit from lighting fixture standards. Moving on now into more specifics around fiber channel.
Okay, great. We have a few questions from the audience.
Yeah, go ahead.
So one is, how is NV standard as a correct? But I think we're going to cover that a little during the presentation. The FCM. And I also got a comment. We're hearing a lot of echoes. That doesn't seem to be the case with everyone. We apologize for that. But,
everybody should mute their phone. Yeah.
So go ahead. Okay.
Joe, maybe you want to mute while I'm talking, or we'll see. Okay. Digging into Fibre Channel a little more specifically, we are an organization under INCITS governance. We have a fundamental model of interoperability provided by what we call the 3 Cs: compliance, conformance, and compatibility. As a standards body, we are always worried about backwards compatibility and forward compatibility. It provides the criteria for interoperability testing. A standard can be thought of as the pass-fail criteria for a test that can be developed. And, if you look, there are organizations that are part of T11 that's their business, right? Their business is to write tests and automate those tests and do testing for partners, independent, right? It's always nice to have an independent interoperability test organization. The standards establish that core expectation that a product has to meet, right? They're backwards compatible, they're plug and play. There are must-haves that, it shall operate this way. It should operate this way, right? So there's some room for innovation here, right? It's a platform, a standard for innovation. You can always add value, right? It's not like there's a big lock on the standard, right? If you want to enhance it, you're welcome to do that. If you want to bring that enhancement back in to make it part of the standard, that often happens. So that's what makes Fibre Channel a trusted technology, right? Because there's accountability there. There's a standard. There's a way to measure the conformance and compliance and compatibility, and that's why we think of Fibre Channel as the right choice and the safe choice if you need to make a technology decision. As I mentioned, this idea of plug and play and security, right? Fibre Channel is known as, and one of the things that most interoperability people worry about is data integrity, and that's why it's trusted. I think I've gone over this a couple times now. There's some shoulds and shalls, and we don't use words like must and might and maybe and while or could be. That there's a very strict language in the standards, and there are certain words that we just can't use because they're too subject to interpretation, which then means it's very difficult to validate. Unlike a specification, if you read some specifications, they're full of language that may not give you a good feel on how it's supposed to work, right? And so that's our standards are trying to make it clear as possible, that you shall do something or that you should do something as a recommendation or as an example of an embodiment. And we sometimes promote, examples and put that in an annex. And the annex in a standard is often, a reference for how you might go about doing what has been specified. So this picture kind of conveys the fact that, T11 works with all these organizations, right? So we're not a silo, right? We work with cable providers, we work with transceiver providers, we work with optics vendors, we work with storage vendors, we work with the Ethernet consortium and IETF, right? Because we need to use Ethernet as part of solutions, to transport Fibre Channel for long distance applications, right? We have to work with the server folks so that the adapters can work with the operating system folks, the firmware folks. So, it takes a community and not just a T11 community to make this whole solution work based on the standards that T11 provides. Joe, over to you for a poll question.
Skip this poll question, Barry. We're a little behind, so we need to speed up. So go ahead and just move forward.
Okay. So, you know, the whole idea, interoperability then, now, tomorrow, a lot of strong points for Fibre Channel that we work hard to maintain. So structurally, you know, we fall under ISO, ANSI, and INCITS is our immediate governance body. And we sit in the middle here, a T11 Technical Committee on Fibre Channel interfaces. INCITS is a parent company. It's part of an ISO formal standards process and provides criteria that we follow. And we break our organization down into sort of an oversight body called T11. And then we break it down into and we align it to the different layers of the Fibre Channel standards. So we have the physical or the FC0 layer, the T11-2 committee, and then we have the T11-3 committee, which is more around protocol and signaling, and I think of it more of the logical layer. So those three basic groups are how we organize, and we develop, you know, the process and follow the process within the construct of those three groups. And we use the T11 as sort of an oversight of the T11-2 and T11-3 work groups, which are comprised of technical experts. And, you know, as we draft a standard, you know, we have a formal review process, as I mentioned. We have a public review is mandatory, 60 days, right? So once the technical committee has drafted a standard and has agreed to that language, we go through basically a 14-day review, and then we have a vote, and that vote can include comments, and then we promote it should the comments be resolved. We promote it to T11, and at T11, there's a plenary meeting every 2 months. A vote is taken, a one vote per company, to see if we can go to public review. Should we pass the criteria, consensus again of public review, the document gets posted for public review, 60 days, anybody's welcome to comment. And at the end of that, we go through comment resolution, and then we promote it to the executive board for their review. And should we receive executive board review, it goes up to INCITS for processing to become a national standard with the ISO organization. So, you know, we like to think of it as we are setting the standard and setting the standards by working with INCITS. We've built this whole process on working face-to-face in group meetings and with voting rights. And I just want to give you a kind of a breakdown. You know, you probably don't realize that, you know, there's over 122 people involved in the T11 organization, right? And if you go down a little bit, right, there's, you know, 57 people doing T11-3 protocol, and there's around 83 people doing physical layer 0, you know, interconnect stuff, because it has gotten tremendously complicated as we've moved into PAM4 and using different technologies to incorporate into that layer 0 to speed things up. But we break it down into voting members, advisory members, and there are people who come to meetings who show an interest, and there's some rules around how many meetings you must attend before you can be a voting member. Once you become a voting member, you have to maintain that voting right by attending the meetings and participating. And, you know, as an accolade to some of the folks who have made tremendous investments and to the standards, we have our Midas folks who are advisors. I like to think of, Mr. Robert Kimmel, who wrote a book, which, you know, really is the first book I read on Fibre Channel. And that's how I got into this whole technology, right? So, you know, we have these Midas contributors, Dr. Bill Ham, you know, a very profound contributor to the standards of T11. So, you know, we recognize people who have made long-term contribution, and we honor them by having them as advisory members of the committee, along with voting members and other advising companies. So there are real people. I just wanted to show you a picture. This is a group of us from February, or was it December? Hard to tell. I think it was December. But, you know, this is the T11-2, T11, and T11-3 committee. All of these folks spend a week working on standards and standards language and editing and bringing ideas in, hashing out those ideas, putting them into the language, how they fit in, how they interoperate, you know, how they advance the technology. So, you know, there are names behind every one of these faces, and they're registered on the INCITS webpage as members from and representatives of different companies. Just to refresh your mind of layers, I mentioned that the committee is aligned to the layers. We have the 5 layers: physical, the encapsulation, the framing, the services, and protocol. And the committees meet and organize around those layers. So here's just a little more, and you know, sometimes it's pretty confusing when you think about you know, the acronyms of FC0, 1, 2, 3, 4. How do they work? You know, from the 4 level, we have the protocol mappings. You know, Fibre Channel is a transport protocol, fundamentally. That was seen as a great advantage when NVMe came about. It was like, wait, that's NVMe is a series of commands. We can transport those commands. And the mapping was done relatively quickly. It was the air handling side of things that has taken a while to understand and document and implement. The common services, right? So you always have your, and one of the unique things about Fibre Channel is that common services, right? I can't really think of any other technology that has a fabric controller. You know, and this is the sort of the switchboard, the heart of Fibre Channel is this distributed service, the name service and the login service and the notification service and the accounting service, right, where you can register yourself and you know, provide information to the fabric about who's available, who's not available, who's talking to who, how do I control who talks to who, right, zoning, right, all these other things. Right. Then we have the basic, how do I send signals? How do I send packets? How do I send frames? How do I manage congestion? Right. How do I do this, you know, on every port? How do I get data? You know, we have this idea of remote data, which can help with diagnostics or with quality of service. Right. And then we have the data link, right, which is sort of, you know, what is FEC all about? How do I encode signals? How do I do, you know, intergap signal spacing? You know, what is my actual transmission protocol? And then we have the physical layer with, you know, how do I get my circuit board? How do my optics transport, right? What is the physical medium, you know, and what are the cables that are required? So those are the basic structures of fiber channel. You've probably all heard this before. We just wanted to break it down a little bit more. There's a security protocol, right, in the network and framing. There's a secure authentication. So another whole dimension of fiber channel is a security standard. There's the fiber channel security protocol standard that's available, which documents many different types of security aspects that can be implemented and are interoperable in the fabric, that makes the fabric secure if you need to do that, beyond just, traditional login authentication and zoning. Port security is one example. So I wanted to just walk you through an example. One quick example is SCNVME2. It's organized around a chair at the T11 level, and there's a T11 vice chair. You can see that the representation is Broadcom and Marvell. And then we have a T11-3 vice chair, which is IBM. The chair is Marvell. The FCNVME2, so we always have a chairman of a new proposed standard, and that's Marvell in this case. And then we have an editor, somebody who's actually responsible for drafting the document. And in this case, it's Broadcom. There's a project proposal. That project proposal in this case was to enhance the protocol, make corrections to the NVMe standard that was previously ratified, and then any other items. And in this case, there were a lot of good ideas that came in to mature the idea of sequence level error recovery. And that's fundamentally what NVMe 2 was about. It was sort of making NVMe hardened and trusted, by providing very robust sequence level error recovery, things that don't have to propagate up and then cause performance issues, things that can be handled sort of in line as they occur. We had meetings every 2 months, and everything that is agreed to is incorporated and then sent for ballot. This is kind of a quick summary of all of the different, starting with Rev 00. We basically took the NVMe standard as a baseline and started marking it up. And then we started seeing all the new ideas come in, right, for sequence level error recovery, and how we should handle keep alive, and how we should handle a lost command, right? And this idea of confirmation entered the standard, and how we process the NVMe commands. And if you really want to get into the standard, how sequence level error recovery was put in as an informative annex on how it gets used. How does it benefit you, and how does it prevent, performance degradation when there are some errors, right? And then we went through 3 iterations of the balloting because there was all this feedback, right? So it's not just a straightforward, let's get the ballot out there and we're done, right? There's a lot of resolution that has to go, and then there's review of the resolutions, and then iteratively getting it correct to the point where we take a vote, and we vote to send it to T11, who then T11 can do a 1 vote per company and promote it then. So as we are sitting here today, right, we have just finished the 60-day public review. And that document, if there was feedback, is being prepared for review by the executive board. And we expect to promote that as a national standard in the next few months, right? So one of the benefits of being part of the standards process is now that you see it reach this kind of point, and it's inevitable that it's going to become a national standard. As a company with a material investment, you can now start moving forward, right, with your support and implementation and feature enhancement, right? Because now, you've got the base for it, and you have a very good solid base. It's not going to radically change at this point. So it's an early signal, hey, let's get working on it. I just wanted to step back on some, we call it funky acronyms, right? What is PI? The interface to the physical media. What is FS? Fabric services. Fabric switch, switched fabric. Then we have the LS, link services, switch services. One of the funny things about Fibre Channel is FCSW kind of exists at 2 layers in the protocol. And referring back to the NVMe 2, because of the NVMe 2 standard, there were other standards that had to get slightly modified, right? So one of the things that the committee does in T11.3 is if we're working on something and we see that it creates an inconsistency or it creates an interoperability problem with, say, LS or with FS or SW or even GS, we have to go back and modify those standards. So one project could result in change to, everything throughout the layers. And that's what the committee's responsibility is to do, is to make sure that there's consistency throughout the processing of a new standard. Some more, we all remember FCOE. It was called Backbone because it was an Ethernet backbone technology. Generic services, which is sort of the upper layer of how the fabric works. There's a specific standard for interfabric routing, and we use that technology when we want to talk to a specific device in a different fabric. Link services, NVMe 2, which is the enhanced error recovery of NVMe. I want to apologize for some of the slides. BrightTalk shifted a few things on me, so please forgive me, but the PDF that you have apparently is okay. There's even tape, right? Today, FC tape is still used as a backup media, a very affordable backup media. And then we have the committees, right? The T11.2 physical variants and 3, the interconnection schemes. So another acronym is FCCT, right? Which is the Common Transport for Generic Services. I wanted to emphasize this because no other fabric technology has central service like this. Now, there are some, as I call it, folks espousing technologies for NVMe fabrics, but no consensus yet, right? And nothing has been brought in as a consensus, to the Ethernet forums. There's a lot of talk. But, Fibre Channel has had this from day one. We have fabric services. We are able to deploy NVMe 2 and NVMe, taking advantage of all of those years of investment in the fabric services protocol. You can zone it, you can look it up in the name server and identify it, and you can scale it, right? So, again, FC NVMe 2 has leveraged these 25 years of development because the standards exist and it was a platform to build a new standard. So the fundamental to that is the fabric login server, the name server, the fabric controller, and the management server, right? All of these things have very well-known protocols and notification mechanisms and scalability, right? So you kind of know what you can do. And you know that some of these technologies have been built out at scale and have been validated, and the different companies will tell you how much scale they validated, right? And so it's not like you have to guess at it. There's quantifiable information in the form of documentation that tells you how to use fabric services at scale. So just where are we today? As I mentioned, T11 3 is doing a lot of work. All of these standards are open at various points. We have the milestones where the technical committees work on the documentation and the enhancements and the technical proposals, and our face-to-face meetings where we review proposals and agree whether to incorporate information. All right, and so you know, no sooner than SW7 moves along, SW8 gets kicked off, LS4 moves along nearly final, and then LS5 kicks off. GS8, you know, it's there, just finished, and now GS9 is kicked off. As I mentioned, FCM VME2 has finished public review and is in what's called pre-edit, clean up some language so that it can go to the EB. And then we have FS6 that just kicked off. And, you know, all of these projects have a project scope statement that you can look up on the INCITS webpage if you want to understand what these new projects are doing, right? But you see, you know, at the end of the day, we get ANSI approval, we become national standards. So we go through this process for your benefit. At the physical layer, right, we're proud to announce that 64 GFC is a national standard. It's been fully ratified. The document is available for purchase at a nominal fee if you so need that specification for your implementation. And so the committee now is working on a parallel version of 64 GFC, right? And it's under development. And, you know, then there's forward thinking. Okay, well, what comes after 64 gig, right? So all of these things are being kicked off as projects and starting to work through the process. So I mentioned FCPI 7. It's now a national ANSI standard. It's built on PAM4 technology, and, you know, it's interoperable, backwards compatible, maintains the reach, supports long distance, and, you know, maintains the data integrity to greater than expectation using forward air technology. Point is, you can now, because it's a national standard, you can move forward, right? It has a material interest. It has an industry behind it. NVMe2, why did we do it? Well, because there are bit errors. There are packets that get corrupted. There are some ways to recover faster if we only had some little bit more information. So we were able to, you know, work with the SCSI folks and FCP5 and to make improvements. Right? So all this was taken on and resulted in some enhancements to the standard using these ideas of conf and slur and flush and red. And again, you can find definitions. All the standards have a section that define these new terms. You know, we can't get to be a national standard without very strict definitions of some of these things. FC parallel 7, right? How do you make 64 GFC work at 256 in a parallel standard? Very much like, you know, 100 gig Ethernet or 400 gig Ethernet, right? So they're parallel standards. That's in committee development right now. And then there's something new that came in that has resulted, now that we have so much telemetry data in the fabric, the telemetry data has found things. that were previously difficult to observe, right? And so that got the committee thinking about, well, we've got this thing in the standard. It's been there for a long time called automated buffer-to-buffer credit recovery, right? And then there was a notification called, buffer-to-buffer credit zero detection. You ran out of credits on a link, let's let somebody know, right? It was a notification. So the idea was, can we challenge the committee to take it further? Can we come up with some idea to address these observed problems with telemetry data? So there's been enhancements, and it turns out that some of the enhancements require help from the ends. And what I mean by that is there's this idea of the R-ready delay. An end device can withhold R-ready and actually cause some pretty severe backups if they hold on to it long enough. Now, we're not going to name names, but some implementations have figured out that, by withholding an R-ready, they can stop traffic. Fundamental, right? That's how BB credits work. So we're coming up with some mechanisms to make that information available to senders so that they have some idea that, there's congestion occurring in this fabric and that there's some way to help mitigate it, and there's a way to signal it. So this is something that's very heavily being worked on right now in the committee. It's not yet a standard, but the text is being refined. So with that, Joe, I'll turn it back to you.
Thank you very much. You did make up a little time, so I'm going to go ahead and push out another polling question. So has your company ever referred to the Fibre Channel Standards? So if the standards compliance is part of your overall purchasing decision, please vote. Or if you use them as part of your design and development, or to my knowledge, the Fibre Channel Standards are not referenced. So voting on that would be great. We did have a few questions. We're going to go ahead and answer them via blogs. But let me see if Barry can take some off the cuff. Barry, one of the questions is, how is the FC NVMe standard, how does it compare to Rocky? Do you have any thoughts on that?
All right, I've been working with Rocky, and I'm working with FC NVMe. So one of the challenges with Rocky is lossless operation. Now, when I work with FC NVMe, I'm not sitting around worrying how to configure the switch and the adapters to operate in a lossless manner. That's fundamental to Fibre Channel. FC NVMe is a lossless technology. Now, NVMe, as a PCI attached standard, was originally drafted for, a lossless operation, right? Because it was only over a little local PCI bus. But now we open it up to over an Ethernet fabric, and now you have the challenge, right? How do you create a lossless Ethernet fabric at scale? So the second problem is, okay, maybe I can get a switch, and we know there are some very dominant players in the Ethernet switch market that have lossless switches, and we use them. But the scale part of it is a difficult issue, and that, caused the idea of Rocky V2 to come about. But even with Rocky V2, there are challenges because of the issues of priority flow control and how that works at scale in a large fabric. So, let's not lose sight of that 25-year investment in Fibre Channel. It's there for NVMe. It's part of the solution, right? We just built on top of it, and we made it more robust, and we made it work at scale. And that's how you take advantage of all this, parallel queuing that NVMe brings to the table, right? So, and Fibre Channel has always been able to have thousands of sequences, out there on the fabric, so we can take advantage of all that parallel queuing that NVMe exposes to the fabric. I could go on about this for a long time, Joe, but I'll stop there. Great question, though.
Perfect. Thank you. Moving forward, after this webcast, the FCIA really likes your feedback. So if you could please rate this event and provide us your feedback and help us make the ones in the future better. You can, we will post a Q&A blog at fibrechannel.org with answers to the questions we received today. You can also follow us at Twitter at FCIA News. Also, we have a library of FCIA on-demand webcasts, everything from this, which is a Fibre Channel Standard, all the way down to FC zoning basics. So if you'd like to put that out to yourself or your team, there's always remote education available. Our next webcast is the current state of FCNVMe. That's on June 9th. It'll be at 10 o'clock Pacific time, 1 o'clock Eastern time. You can go ahead and register at the BrightDoc link as you see it on the screen. And with that, we hope you found this webinar educational and that you're able to make the use of it to improve your Fibre Channel network in your data center. Thank you again for attending. Please look on the fibrechannel.org website for additional material. Lastly, to keep up on dates in the Fibre Channel world, you can sign up for the FCIA quarterly newsletter. Again, that's on fibrechannel.org on the homepage. And with that, wash your hands, keep a proper distance, and everybody keep healthy and safe. Thank you, and everyone have a great day.
Thank you, everybody.